Good morning, everyone. It's your boy Phillips Oladile Olamide, aka Philosopher. So, I'll be taking you through organic chemistry courses, representing you guys' education. So, before I will proceed, I want you to do something for me fast. You can pause the video. Please subscribe to this channel and like the video. And after then, you can continue with me. All right. Once again, I'm Phillips, also known as Philosopher, and I will be taking you through the organic chemistry courses on reactions of alkene and alkynes. Okay, so let me start with this. You should know that chemistry is divided into two by now: organic chemistry and inorganic chemistry. And organic chemistry is actually centralized on element carbon. When carbon now reacts with hydrogen alone, mostly, we call them hydrocarbons. And under that one, we have the division of aliphatic and aromatic hydrocarbon. Aromatic hydrocarbon are the family of benzene and toluene and the like cyclic compound that have three, at least some double bond. But aliphatic hydrocarbons are hydrocarbons that can be straight chain, branching. They can also be cyclic, but they derive their name from the word fat, alipha. So that's why we call them aliphatic. And they are just three. And it is the alkene, alkene, the alkene, and the alkyne, the ane, the in, and the I. Now, the ane, one of the characteristics that you must actually be familiar with about ane, alkane, is that they contain single bond. You can never find anything double bond. They all contain single bond. Alkene, you may, as well as, of course, you may have some single bond, but at least you must find at least one double bond. So when you see that, that means the compound is actually an alkene. Then when you see at least one triple bond, that means you're able to identify that compound is alkyne. Now, one thing that we know about the nature of alkane, ane, is that they are saturated. A typical example is the ethane, like the one of two carbon, ethane. And each carbon has to be surrounded by 4 bonds. Ethane, let me give you ethane. Ethane contains 2 carbon, and each carbon needs 4 bonds, but already the 2 of them have shared a bond. So this bond is serving this one as 1, and this bond is also serving this carbon 1. That means each of them only need 3 more. So to complete their bond, I will have to include 3 hydrogen. Are we together? But to form alkene, instead of writing 3 hydrogen with the carbon, we are going to reduce it by 1. Therefore, it remains 2. What you have done is that you have removed 1 hydrogen from each carbon, and those 2 hydrogen are always regarded as sigma bond. So if you remove 1 from here, 1 from here, 1 sigma bond from here, and 1 sigma bond from here, the 2 will form a pi bond. Know it now. When you add 2 sigma bonds together, you will form a pi bond. So destruction or removal of 2 sigma bond, which a representative member can be hydrogen. Hydrogen is a proton, and it can represent a sigma bond. So far, you remove 1 element that can bond 1. Example is hydrogen. In this case, it is 1 sigma. But I remove 1 sigma from here, which is hydrogen, and I remove 1 sigma from here, which is hydrogen again. So destruction or removal of 2 sigma bond will give pi bond, and that pi bond will join this one at the middle, then making it to become double bond. So that is what characterizes alkene. So you can now actually summarize this now, that we derive alkene from alkane by the removal of just 2 hydrogen. Then you can as well transform this alkene, because this is ethane. Sorry, let me write it. This is ethane, and this is ethyne. I'm trying to create ethyne now. Now you can as well actually create ethyne from ethane. How? Remove 1 hydrogen more from each carbon. So if I remove 1 from here, that means this carbon is only left with 1. I remove 1 from this 2 that is left, this carbon also will remain 1. So that means already there's double bond from here. But because of the removal of another 1 hydrogen from each carbon, which is sigma bond, there's another creation of another pi bond. So we can therefore call this reaction elimination reaction. I eliminate 2 hydrogen from here, I get 18. I eliminate 2 hydrogen atom from 18, I get ethyne. So you now call the name of this compound ethyne. But one thing we have actually discovered is that this formula that you see, they are called condensed formula. Condensed formula is a formula that shows how you share your proton around a centralized atom. The proton here is hydrogen. Each carbon share the hydrogen. They share the hydrogen. So that formula that is showing how you have shared your proton around the mother carbon because of the carbon is called condensed formula. But we have another type of formula in which you show all the structure. You will show all the bond, how the bond orientation, and that's the structural formula. So let's draw the structural formula for all these compounds. For this one, you said this carbon is having 3 hydrogen. So you must show the 3 hydrogen surrounding the carbon on all sides. Don't forget there's one bond here between carbon to carbon. That's catenation. Then the other carbon too, this carbon, you said it also have 3 hydrogen. So you put it. Now, that's for this one. But for this, you will notice that this compound, each carbon here is surrounded by 2 hydrogen, but there's still double bond. Now, what we are saying is that in actual sense, and let's draw this one too. In chemistry, reaction lies on how many pi bond do you have. The more the pi bond you contain, the more reaction you can do. Now, just assume that this guy this alkane need 4 bond per carbon, and if you can see, all the side is singly bonded. There's no free space. Every side is bonded. So that's why in terms of reactions of alkane is limited because they are saturated. All the sides are singly bonded. There's no space that is left over for an attack or reactions. So they don't make friends. They don't react a lot. But alkene, at least, because there's only 2 hydrogens surrounding the carbon, and this side is empty. This place is empty. Nothing is here. And here too, nothing is here. So reaction can occur here because there's a pi bond here. Understand now? And then here, this one on top is pi, while this one down is sigma. So that means you can say alkene contain 1 sigma, 1 pi. 1 pi, this pi, this is the symbol for pi, your normal pi, and this is sigma. 1 pi, 1 sigma. While alkyne contain 2 pi, 1 up, 1 down. Then this middle one is the sigma. So the chemistry of reactions, when we mention reactions, we are simply talking about the pi bond, reaction of your pi bond. So whenever we are talking of reactions of organic chemistry, we do not have a lot of concern or so much concern with alkane, the ANE. No. Our concern is on ENE and YNE, the ene and the yne. So because it's only in, it is from in alkene that the addition of pi bond started. In alkane, there's no traces of pi bond at all, since there's no double bond. But from alkene, we begin to have at least 1 pi bond. And in alkyne, the pi bond becomes 2. So the chemistry of reactions lies on pi bond. Do you get what I'm saying now? So I'm only going to explain this understanding in this video. So please try to subscribe to my YouTube channel and stay tuned for more videos. So the next one I'm going to do is to bring to you some of the reactions of alkene and alkyne. Well, I know by now you must have been able to know why alkene and alkyne are the most reactive, or they are the most concerned when we talk of reaction. We don't always talk about alkane, ANE. Alkane, the first one that you know in aliphatic hydrocarbon, alkane, ANE, does not have a lot of reactions. Why? You must have known now. For quick access, let me just recap and you meet me in the next video. Now, what I'm saying this morning is that, let me just make a summary. I think the board is rough. Now, as you can see on the board, these 2 guys are unsaturated. the number of hydrogen that is required is not sufficient. That's why we have to double bond and we have to triple bond. So the second bond or the other two bonds that join the alkyne to make it triple are called pi bond. So in alkane that is already saturated, everywhere is single bond. So there's no need of pi bond. And I said the chemistry of reactions depend on pi bond. So alkane does not have a lot of reactions to consider. So when you hear reaction in chemistry, your mind should go to alkane and alkyne. And there's a lot of interesting reactions that these guys undergo. But in actual sense, in order of reactivity, actually, alkyne is most reactive. This is reactive, more reactive, and most reactive. Alkyne is more reactive than alkene, and alkene is more reactive than alkane. But as we know, too much of everything is bad, and too low of everything is also dangerous. Now, alkane lack pi bond, so there's no reaction. So it's not as reactive as alkene. And alkyne has more pi bond than alkene. That's too much of pi bond. So in actual sense, in reactivity, alkyne is more than alkene. But in the reaction that alkene undergoes is more than that of alkyne. Because alkene is at the middle point of reference. Alkyne only have one pi bond together with the sigma. It's not much. It's balanced. But alkyne has two pi bond overcoming or blending with one sigma. So the reaction is not too much, though it's also reactive. So as time goes on in the next video, you will see how I will show you the reaction of alkene is about 13 or so, and that of alkyne is like about 10 or so. So even alkene, which is not even more reactive than alkyne, has more reactions than alkyne, because alkene is at the middle point of reference. It's not too much and it's not too low. One pi, one sigma. While alkane does not have any sigma, any pi at all, no pi bond at all. But alkyne has more than one pi bond, two pi bond for that matter. So alkene is the most contain most reaction, not the most reactive, mind you. In organic chemistry, alkyne is the most reactive when you are comparing these three guys. But in number of reactions, alkene has more reaction than alkyne. Simply because maybe alkyne has excess of pi bond and alkane has no pi bond at all. But alkane maintain the balance. See you in the next video. Love you. Please stay tuned to You Guys Education. God bless you. Love you so much. Bye.